So thank you for having you back in the boardroom. So we will go straight forward with our next talk. The next speaker is the founder of freistil Box, which is a managed hosting platform company based in Dublin. He is also very famous or well known for his talks on community conferences and his activities in the Drupal community. But today he will not present us something about Drupal. He will give us a talk about Sensu. So let me introduce you, Jochen Lillich. Thank you.
Thanks a lot, and welcome to my talk, Monitoring with Sensu. Fortunately, thanks to recent advances in time travel, I've already finished this talk. Thanks for the great discussion. Let's go and have lunch. Thank you. Okay, I've covered this topic before at OSMC back in 2014. Here we go. Yeah, the year before, we had run into severe load and queuing problems with Nagios, and our hosting platform started to grow faster, and Nagios simply couldn't keep up. I learned about Sensu at DevOps Days London, where Ulf Mansson contradicted the then popular monitoring sucks hashtag in his talk, Monitoring Love. So we gave Sensu a try and never looked back. Sensu is still awesome and deserves an updated talk at this open source monitoring conference. Who am I? My name is Jochen. I'm the founder and CEO of freistil IT, a team of managed hosting experts based in Germany, where I started the company in 2010, and in Ireland, where I live. Why would you use Sensu? Well, first of all, it's easy to set up, so you can give it a try without losing a lot of time. It can grow with your infrastructure, which other monitoring systems, Nagios, can't. You can reuse the checks you already have and that are readily available on the internet, checks for Nagios, for Icinga, for Zabbix and other monitoring systems. Sensu can collect both health metrics, the typical status checks, and metrics in the wider sense that you might pass on to something like graph height. And it has a great open source community that is very helpful. Speaking of open source, Sensu does a dual licensing thing where they have an open source part which is named Sensu Core and is licensed under the MIT license. You have great support on mailing lists, on IRC, or if you are one of these hipstery types, you can also use Slack. Sensu was created in part-time by Sean Porter at a company named Sonian. Today he is the CTO at Sensu Incorporated. The other side, the commercial side, is Sensu Enterprise, where Sensu Incorporated does the typical consulting and support gig, where they offer more of a product that is based on the Sensu Core framework, and that product comes with everything that Sensu Core has, and on top of that, they add additional things like contact routing, built-in handlers, which with Sensu Core you need to install manually. It does things like metrics conversion and has lots of service integrations out of the box. It also has features like a heads-up display, which is more or less a dashboard. And of course, you can buy commercial support and training from Sensu Incorporated. If you'd like to give it a try, It's very easy to do. Sensu is written in Ruby at the moment and uses a concept named omnibus packaging where everything you need to run comes with Sensu. So it has its own Ruby distribution, it has all the gems that are necessary, and you don't get into the dependency hell that gems sometimes can be. Sensu is also easy to configure. It uses a bunch of JSON files that you need to set up, and of course that is most easily done by automation. There are Chef cookbooks, Puppet modules, and Ansible playbooks that can set up Sensu within a minute. The main advantage, of course, of automation is that you'll never forget to add new machines to your monitoring systems, and that knowledge that is already in your automation system can be used to set up your Sensu clients. I'll get back to this at a later stage. So how does Sensu work? As we all know, building a monitoring system is very easy. You'll need a monitoring client that executes the checks. You need a server where the server talks to the clients and the clients talk to the server. And you need some place where alerts are generated. Unfortunately, some people take this literally, and then the result of that is things like Nagios. But if you take this more as an abstract description, you'll get Sensu. So these are the parts of a Sensu system. You have the monitoring agents down there. You have the central server. There is a way where which servers and clients can use to communicate, which is, in this case, a message bus, mainly RabbitMQ. You have a system where state is persisted. Sensu uses Redis for that. And Sensu also offers an API that you can use from command line commands or from web user interfaces. In practice, that makes things very simple and very performant. The monitoring agent almost has more intelligence than the server in this case. It registers automatically with the server, so you simply tell the agent to which server it should speak, and it registers itself, and regularly sends keep alive information so that the server knows if some client has vanished. It receives check execution requests from the server via the message bus, or it can also schedule checks autonomously, locally. It then executes these checks and returns the results of these checks back to the server. You can also feed external events into the monitoring client, for example, from an application, from shell scripts and other places, and have these events also be transferred to the server. That makes some things very easy, and I'll show you an example later. So how does the normal check cycle work? The server has its schedule and knows, okay, some of these checks have to be executed minute by minute, others every 10 minutes, or others only once a day, things like that. And Sensu uses a publish-subscribe mechanism and doesn't actually talk directly to the clients. And that makes this very scalable, because all the server does is publish a check request. For example, hey, all you web servers out there, let's count your Apache processes. And that's all the server does. This request is received by all the clients that have the web server subscription. So it's a client setup thing here. The clients execute the check, and the check tells them if the result is okay, warning, critical, or something else, but mainly these three states. And they return these results back to the server. So basically, all the main monitoring work is already finished. A check has been executed and its result has been interpreted. The server then receives these requests and triggers event handlers that do something. So it might be that all kinds of results get posted to Slack, and only the critical results get passed on to something like PagerDuty, for example. So all the server does is basically event handling and scheduling new events. And since things get persisted in Redis, you have the API that you can use to get recent check results, to get client state, to get everything basically that you need to display on a dashboard, which comes included with Sensu, but you can also use third-party dashboards or command line interface commands. And that's how the default dashboard looks like. It's called Icinga and simply lists all the current states of your checks. The API is REST-based and gives you access to all the internals, so you get information about the monitoring clients, about checks, if a check is disabled or silenced, about events, results. You also have an Aggregates API that allows you to monitor clusters, where you only are interested in total results, not the single parts, and a Stashes API that gives you access to the Redis storage. As I already mentioned, checks are the central part in a Sensu system, so let's take a closer look. Checks are executed by the Sensu client and are simply external applications that get launched by the monitoring agent. So you can use everything that is executable, shell scripts, Nagios checks. You can build them yourself, or you can simply download them. Sensu, of course, has their own GitHub repository where you can download a lot of checks for all kinds of things that you might want to monitor: network, appliances, servers, all the whole spectrum. By default, events are only generated if a check returns a non-zero result, with the exception, pardon me, with the exception of metrics checks that and events that always trigger an event. And since the parameters of a check might vary between different machines, Sensu has a token substitution approach where you can, for example, define thresholds with a placeholder. for example, the check, the Apache process check might have different thresholds on different machines, and you simply use a token process critical, for example, and that token gets replaced with a value that depends on the machine. For some machines it might be 10, for other machines it might be 100. And that makes it very easy because you can put the actual values in a client-specific file on each machine, and your check definitions look the same on every machine because they only use these placeholders. Triggered are these checks by default by the Sensu server. So you need to define the intervals in which these checks need to be executed. And normally, the client subscriptions reach all the clients that subscribe to a certain name, for example, web servers. But there's also now a round-robin subscription where you can define, okay, web servers are these 5 machines, and I'd like only one of these machines to return a result this time, and then Sensu goes through the list and starts from the top and cycles through every machine, but the check itself is only executed by one of them at a time. If you need to be more flexible, you can also have the Sensu client itself start a check. You might trigger this with cron, for example, or by simply defining an interval, and the Sensu client will then execute the check autonomously and return the results to the server. And of course, the API also gives you the possibility of triggering a check manually. And that's how a common check definition looks like in JSON. Here I'm defining a disk-free check. It's a status check that returns a result in the terms of OK, warning, critical. I'll have all my machines execute this check, so all my machines need to have the all subscription configured. I'm using my default set of handlers, which are defined separately. So the default set might be Slack and PagerDuty. And the central thing is the command. In this case, I'm reusing a Nagios plugin. And here I'm using the substitution tokens, which get replaced by the Sensu client and are defined in a client JSON file. And the default interval for this check is 60 seconds. And that's what I meant, that Sensu is really easy to install because the application itself, with all that is necessary, so Redis and RabbitMQ come out of the box. And then you simply add these simple JSON files, define a few checks that you most often can install from operating system packages, and you're good to go. If you'd like to automate that, there's, for example, the chef cookbook for Sensu, where you can use the chef DSL to define a check. So the Sensu cookbook has its own Sensu check resource. Here I'm defining a check named MySQL Server. I'm defining the command, and again the handlers and an interval, in this case 30 seconds. And in this case, I'd like this to be a standalone check, which means it gets started by the Sensu client. It doesn't get triggered by the server. And that's because I'm using a very client-dependent information, which in this case is the MySQL password. And the fact that I'm using a password here makes this a bit ugly. Because why? Well, first of all, the password will be in plain text in the check definition on the machine, which we could use with typical file system permissions. But also, this password, since it's part of the command, will be passed back with all the result information. So the password will go over the network to the Sensu server and might even be displayed on some kind of monitoring dashboard. And we don't want that. And that's why Sensu allows you to redact information. And that's exactly what I'm doing here. This is a very simple client configuration file, which, for example, defines its name and address. It has a list of its subscriptions, in this case, only the base subscription, whatever that means. And here I have a redact section that defines the list of attributes that I don't want to be passed back to the server. So every attribute that is named password will be redacted. And in this case, here I'm defining a client-specific attribute. So all the attributes that aren't predefined by Sensu will be client-specific. And here it's MySQL and password. Together they form an attribute MySQL.password, which I can use in my check definition. So I'll simply use the substitution token, 3 colons, MySQL.password, and again 3 colons, and that's that. And when this check is executed, the information that goes back to the server is literally command something something password or minus p. Let's go back to that. Minus p redacted. So you see there was a value that has been removed by the Sensu check. That's the other kind of check we can have, a metrics check. And that simply executes some kind of Ruby script named load metrics. It gets executed every 10 seconds by all the subscribers to production. And all this check does is output the current load values in a common format. This is passed back as payload to the server, and now it's up to the handlers that I'm actually using what happens with this information. So I might have a Graphite handler that reacts to metrics results and takes these results and forwards them to some kind of Graphite server. Still quite new is the concept of check hooks, which are additional commands that the Sensu client can execute if a check returns some kind of result. In this case, I've highlighted this hook, which does an Nginx restart if the check result is non-zero. If the check result is critical, sorry. If it's critical, it tries to restart Nginx. And in general, if the result is non-zero, so this will cover warnings as well, I'll simply execute PSAUX, and that will be passed back to the server. So these check hooks allow you to do some kind of simple problem mitigation. Of course, this is not very intelligent. So, for example, the Sensu client does not know the check's execution history. It does not know when this check was executed last. It does not know if this check is flapping. It does not know the number of state occurrences. So has this been critical for 3 days now? Or if the check is silenced on the server side. So you're pretty limited, but you can do some kind of auto-remediation. Another way I can trigger events that get passed to the server is by simply using the local client port 3030. And you can access that port via TCP, via UDP, and now also via HTTP. And that allows you to feed any information back to the Sensu server. In this case, I'm defining some kind of external event called myCheck. I'll pass it some output and a status that decides if a handler will be triggered on the server side, and pass that into the TCP port 3030, and that's that. There's a nice helper script on GitHub that makes these things easier. And there's some nice additional possibility that you can use. If you pass a TTL attribute with this information, you can build some kind of dead man switch where you can say, okay, this result needs to occur every minute, for example. And as soon as that changes, the server will know that something's fishy. For example, if that script doesn't get executed anymore, the Sensu server will know, okay, there was some kind of thing named myCheck that had a TTL of 1 minute and hasn't occurred in the last minute. And then you can also, again, trigger some kind of handler. And you don't have even to have a proper check for that. Simply the fact that you passed in something that had a TTL lets the Sensu server make some kind of important decisions here. I've been talking a lot about handlers. Let's take a closer look. Handlers are simply applications that get executed by the Sensu server, and they get passed the event information on their standard in. So again, you can use any kind of application, shell script, Ruby script, whatever, as an Sensu handler. They can be accessed via TCP, via UDP. Then there are transport handlers that put information back on RabbitMQ, and you can define handler sets that group a number of handlers. So you can use that as a simple alias method where you have a handler that also has is accessible on another name, simply by defining a group with that name, or you can use it in the original sense and have some set of handlers that get the same event data. And of course, there are a lot of handlers available already, for example, for third-party integrations, for things like PagerDuty, for things like Slack, IRC handlers, everywhere that you'd like to pass monitoring events can be reached by handlers. So the common handlers that are regularly used are email handlers that simply send your event data to an email address. PagerDuty, you can, of course, pass especially metrics events to Graphite, or you can use Slack to get a running log of your check results, and here's an example for that. If you'd like to build your own handler, that's also very easy. In this case, I've done a small Ruby example that simply takes the event data from standard in, parses it as JSON, so I'll get a nice hash, and then I'll simply create a file system file and write the event data into that file. That's all this does. Of course, that's not very practical, but it's a nice example. And the related configuration file is very simple as well. I'll simply define a new handler called file. It's of the type pipe, so it gets the event data via standard in. And I'll define the path to the command that the Sensu server should execute. And that's that. Other handlers might, of course, have additional attributes. For example, you'll need an API token for PagerDuty or things like that. So the JSON hash might get more complex with other handlers, but still, it's easy to understand. And I like that very much about Sensu. Another thing that stands between the Sensu server and the event handlers are filters, where you can define conditions under which event data is passed to a certain handler. You'll simply put a filter in front of a handler and can define conditions that take parts of the event data to decide should this event actually be handled or not. So that might be handy to cut down on the number of Slack messages. In this case, this is a handler that only, a filter, sorry, that only activates the handler if the state has changed. So it only the handler only gets executed if the check state changes. And it only applies to checks that have the interval 60 seconds. What I've done here is mainly I'll filter on the occurrences attribute of an event that tells me how many times has this event occurred. Normally, I'll simply trigger if occurrences are 1, so just freshly changed. So normally I'll get OK, 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 and this filter only lets the first OK pass. And when the check goes to critical, again, the first critical goes back to the handler, and the second and all subsequent criticals don't. And if it changes back, well, you know the drill. The only exception is if I resolve a check manually, the occurrences value gets reset completely and is 0, so I'll have an OR condition there. If the action was resolved, I'd like to trigger this handler as well. You can also use this to only trigger events during office times. So Sensu also offers conditions that are based on the current time, things like that. You can be very creative here. Another useful function of Sensu are aggregates, and that gets interesting if you are monitoring clusters of a server. Because aggregates require contextual knowledge, these are only available on the server side. You can't use aggregates on the client side. You simply define a check as aggregate, so Sensu will collect this information and say, okay, for all my web servers, for example, I got 3 OKs and 1 critical. And it writes that into Redis. And this information is then available via the Sensu API. And there is, for example, the check aggregate plugin that then queries the API and might, for example, ask, okay, give me the aggregate for web servers, and then trigger an event if I have more than 2 criticals in there. That makes it very easy to define cluster checks where you say, okay, I'm fine. If only 10% of my web servers are offline, I can deal with that. And that doesn't need to trigger a nightly alarm, for example. And as soon as the number of criticals goes above 10%, then the check aggregate check will trigger an alert, as any critical check will do. These are the basics, and so far it should be pretty straightforward. Now let's get to practice. How do I operate Sensu on a day-to-day basis? Well, apart from the Sensu dashboard that I showed you earlier, there are command line commands that you can use for common things, mainly the sensu CLI command. And there are also API connected things. Even chat ops is possible. There is, for example, a UBot integration for Sensu, where you can request, give me all my critical checks at the moment, and you'll get them listed in Slack, for example. Another thing that's often forgotten is monitoring your monitoring. Sometimes there are times when I ask myself, is monitoring still up because my on-call shift is eerily quiet? Happily, Sensu uses very common components that are well proven in practice, and where there are best practices for monitoring them. So let's get back to the architecture. How do you monitor Redis? Well, that's a solved problem. How do you monitor RabbitMQ? Also solved. How do you monitor an API that's reachable via HTTP? Well, that's easy. The server can be monitored via its port. The clients can be simply monitored by some kind of local software like Monit, for example, that make sure that clients are running. But if a client disappears, its keep alive check will trigger the server anyway. So monitoring Sensu in total is very straightforward. One practical tip: make sure to monitor the RabbitMQ ready queue, because that might become a bottleneck, especially if you do metrics monitoring. There's a huge difference between executing, say, 30 health checks on a machine every minute, or collecting 250 metrics every 10 seconds. And especially if you're doing this kind of metrics monitoring via Sensu, you might want to check that RabbitMQ doesn't back up. But other than that, Sensu is very easy to deal with. How does it scale? If your infrastructure is growing as ours is, it's important that your monitoring system can keep up. And again, this is very easy. For the standard open source components, there are proven ways of scaling Redis. And since a recent version of Sensu, it has native support for Redis Sentinel. So running Redis in a scalable and even highly available configuration is easy. There are known ways to scale RabbitMQ. And with regard to Sensu itself, Sensu makes things very easy. Again, scaling the API, if at all necessary, is like scaling any web application. Put HA proxy in front of a few web front ends and you're done. And in terms of scaling the server, which might become a bottleneck if you have to execute a lot of event handlers, is easy too, because you can simply spin up more Sensu servers, connect them to RabbitMQ. They'll even do an automatic leader election, and you're good. What if you have multiple data centers? The most straightforward approach would be to simply run Sensu at a central location and have every client connect to your RabbitMQ at the central location, which then works as normal. This architecture is very simple. You don't need any additional infrastructure. You have centralized alert handling. But the downsides are pretty easy to spot as well. You won't be able to distinguish the breakdown of a WAN connection from client timeouts. So if a client doesn't report back within the default of 3 minutes, which you can change, you don't know, is it simply because we have some kind of network outage, or is it actually the client that has disappeared? And of course, if you have lots of remote clients, that will generate a lot of network traffic and a lot of TCP connections, which might become a bottleneck. And from a user perspective, all these clients seem to be in a single data center. You can't really tell which client hails from where. So there are two other approaches that you can use. One is the federated approach, where you put a RabbitMQ broker into each single data center, have the clients report locally to this broker, and then collect all these messages in another central message bus, and then have the default Sensu server setup. You have a little bit more infrastructure in each data center, but it's only a RabbitMQ instance. The alerts, again, get triggered from a central instance. The downside is your RabbitMQ architecture has become a bit more complex. Again, all clients still seem to appear from a single data center. You don't have that separation again. And if your network connections are unstable, you might get a lot of keep alive alerts that actually come from a network outage. And then you can put even more infrastructure into each data center. In this case, the full Sensu setup with a message bus and a Sensu server in each data center. And now you have pretty much localized your monitoring and aren't as dependent on wide area network infrastructure anymore, and simply have your dashboard connect to multiple servers, which is also possible. Network outages will not create flapping. Sensu will still work if a whole data center goes down. This infrastructure is easier to understand because you have a simple setup only per data center. And now the dashboard can distinguish where the events come from because they come from different servers. But that comes with its price, as you can see. Sensu development makes pretty fast progress at the moment, and so a few things that are down the pipeline are scheduled maintenance, which Sensu doesn't have at the moment. You can silence checks, but this will be instantly. So far, you'd have to use something like the old classic @ to execute silences at the right time. Scheduled maintenance will be there soon. And Sensu promised official Docker images that will make setup even easier than it is now. And in the long term, the Sensu core team is already working on a version 2.0 that won't be written in Ruby anymore, but in Golang. So to summarize, it's really easy to get started with Sensu, and it can handle growth, which basically saved our asses back then, because we could instantly take our Nagios checks, use them with Sensu, and it's a much increased performance. And now we got our check results within 30 seconds and not within 3 minutes, as it was with Nagios. You can use the Sensu infrastructure that you have in place to collect metrics as well. So you don't necessarily need something like collectd or statsd or something like that. You can simply execute metrics checks like the simple script I showed you, collect data, have them travel across RabbitMQ back to the server, which then passes it on to your metrics database, which might be InfluxDB or Graphite or something similar. So you don't necessarily need metrics collection agents as well if you have Sensu in place. And Sensu integrates with a lot of services that are common in our space. So it's easy to use with existing services and infrastructure. Or shortly, monitoring love. Thank you.
So thank you, Jochen. So we have a lot of time for questions left. So if it's okay.
Yeah, sure.
Question?
Shoot.
One question, can I make conditional filters, like if some network metrics are not right, I trigger alerts, but for example, the WAN broke down, and I don't want to trigger an alert from the data center because it's a problem in the WAN. Can I filter it on one side so it only executes an alert if there's a real problem inside the data center?
So basically you want to avoid false positives. If your network goes down, you don't want to have hundreds of checks trigger an alert. Yeah, that's possible. That's actually possible by combining event data and, well, your check will be a bit more complex and you'll need a bit more complex of a filter, but that's possible, yeah.
And it's all, it happens on the client or server side, whatever is more reasonable.
It has to happen on the server side because the server has all the contextual information, and then you can do things like that.
Thank you.
What about hosts that are only API or web servers with no agent installed on it? Could I configure a host in Sensu that is only available via HTTP? Or just like something in the load balancer appliance also?
The only problem you have to solve here is where does my HTTP check get executed? If it can't be on the machine itself, simply by connecting to localhost port 80, for example, you simply put that check on another machine and tell it, okay, execute the normal, say, Nagios HTTP check, but with this address.
Okay.
And
I
then
need something like a worker node.
Yeah.
Okay.
You'll always need some place where you execute these checks. Most of the time, it will be the machine the service is running on, but sometimes you may have to do it externally or may want to do it externally because simply that I can talk to port 80 on localhost doesn't mean that my website is available from the outside. So you might even want to have that external machine that does HTTP checks from the outside.
Can you please tell a little more about the size or the sizing you have in freistil or your infrastructure and how you solved your setup with Sensu? Because you said it solved your problem with Nagios, but it's I think it's more clear when you explain how you solved it and what was your problem exactly and how big is your infrastructure to get a feeling for that.
So back then, our infrastructure wasn't that impressive, but the thing is, we had the standard Nagios setup, and the number of checks we had still started to cause check latency, as I said, in the range of minutes. And of course, that's not optimal. So what we did was move all our critical checks over to Sensu, which took us about less than a week to get Sensu running and get all our checks configured there. Since we used Chef, which we already had, to automate the setup of each client, that was quite straightforward as well. And at that stage, our current problem was already solved because Sensu handled that amount of checks, basically the same amount that we had with Nagios, much more gracefully. And so the bottleneck was removed at that stage. Since then, our infrastructure has grown. So we run a few hundred servers, dedicated servers at Hetzner. On each of these machines, we have lots of Linux containers that act like hosts. So they each have even a Chef client and a Sensu client. So the number of Sensu hosts at the moment is probably in the range of 500 to 700, somewhere like this, with the typical status checks that you have for each machine, load, CPU, disk space, and all that thing, and additional checks depending on services. These checks are executed between 10 seconds and 60 seconds. Some checks only run in intervals of half an hour, for example. Disk space has a higher interval. And so far, we haven't run into any scalability issue at all. So we are still running the simple setup with one Sensu server, one RabbitMQ, and one Redis instance. And there is no load issues at all. So we expect to be able to grow a lot by a multitude without Sensu breaking a sweat.
Just related with the size of your database for the data you have.
The size of the Redis database that Sensu uses?
The size of your collected data.
I wouldn't be able to tell you from the top of my head, but I can look it up for you if you like.
Yeah, it's interesting.
But I don't expect it to be very big because it's only check history for recent checks and basically the collection of states. If a client has been silenced or if a check has been silenced or deactivated at all. So I don't expect the database to be huge in this regard. Everything that is time series data gets pushed to Graphite in our case, and so the problem is not on the Sensu side.
Hi, I have a question related to high availability capabilities for the Sensu server. Because when you show the second picture with the two Sensu servers separated, there was no communication between them. So do you use the same configuration from one server and copy to the other, or how do you do?
Well, that will probably depend on your service architecture. If your data centers are pretty much separate, you don't have the need of Sensu servers sharing context because each server is its own world, so to speak. If you have things that are interconnected, you'd probably have to do a bit of engineering yourself. For example, work with aggregates on each island and then have some external intelligence, external logic that will take these aggregates and tell you if a service that is geologically distributed is okay or not. Sensu itself won't be able to tell you that.
Okay, I have more questions, but okay. When you were talking about aggregation, it sounded like a kind of a business process module. Do you have something like that where you can set up rules saying if these couple databases and these couple HTTP services and this couple whatever makes a whole thing, then if this is working or this other is not working, then I will raise an alert? Does it work like this or no? It's just for clustering and that's all?
Sensu itself is very light on that side. I didn't point it out, or I didn't emphasize it, but it's basically if you do an aggregated check, all that Sensu does is collect all the check results and store them, and that's it. So you'll have to do this recursive approach that I mentioned, where you have another check configured that is completely separate in terms of context, where you execute this check aggregates check that goes back to the information that had been collected as aggregates and then draws its own conclusions from that data. But so it's basically doing checks on checks in this case. And with that approach, you can be as complex as you like. You can write a whole sophisticated application that uses the Sensu API to get all the raw data and draw its conclusions from that, and then put back another event that might trigger some handlers and things like that. So basically, you can make it as complex as you like, and Sensu gives you the building blocks for that.
Okay, and then another question.
Go ahead.
With how many checks do you have to put a new broker for the RabbitMQ?
That's hard to tell and will probably at least depend on the hardware you are using. So your mileage may vary.
You are not saying any numbers.
I won't be able to tell you any numbers now, because it's really about the number of events that you trigger, the number of the size of the payload you generate. My simple load metric just printed 3 lines. If you have something that writes out kilobytes of data, this will be pretty different. So my only answer can be at this place, it depends.
Okay. Thank you.
So next questions.
Yeah. Hello, I have 2 questions. Is the communication between the server and the client encrypted? And the second is, when there is a problem at the server side, will the data be cached? So the metric data that will be collected on the client.
Sensu uses SSL encryption, so you can set up either a common certificate that is deployed to all the clients, that would be the most simple configuration, and you can go as far as you like in terms of having individual client certificates as well. And to your second question, that's already built into the infrastructure. If your only Sensu server goes down, what happens is that the messages will stay in RabbitMQ. Okay. And as soon as your server comes back, it will process everything that has piled up. I was only half joking by saying building a monitoring system is easy, because if you are using the right building blocks, it actually is easy, and you're basically standing on the shoulders of giants named RabbitMQ, Redis, and so on.
But the client don't cache, so that must be delivered to the RabbitMQ. Or is it part of the client?
RabbitMQ is the crucial part here. If your client can't connect to RabbitMQ, it won't be able to put the message on the bus, and your result will probably get lost. So if we are talking about high availability, RabbitMQ should be the first place you look at.
Okay, thank you.
Till Sensu 2.0, now everything is written in Ruby.
Yeah, so far everything has been written in Ruby, which is nice for us because we had to learn Ruby for Chef anyway. So a nice little detail is that Sensu 1.0 is only a few weeks old now, and all they did was take Sensu 0.29, I think, and relabeled it with 1.0. And the only real thing they added to the 1.0 release was the promise that Sensu will now have semantic versioning. So 1.0 is what was 0.29. No major change happened with that release. I can imagine that with very large infrastructures, they'll run into some kind of bottlenecks that won't be easy to resolve using Ruby, and that's why they now look at Go as their new language. But 2.0 will probably be mid-term, not short-term.
Okay, and do you know of any backward compatibility or grace period?
I'm pretty sure that 1.x will be available for a long time. And again, taking this architecture, it will be quite easy to simply replace a Sensu server written in Ruby that only executes some kind of script as a handler with the same thing that's written in Go. I expect this to be pretty easy to do.
Are you able to handle external events like SNMP traps or syslog messages with Sensu?
Mm-hmm. There are also checks that query SNMP or things like that.
And not querying, getting external events like an SNMP trap.
Oh, okay. I'm not sure because we are not using SNMP at our company, and so I don't have any practical experience with that. I could be able to look it up because the check repository on GitHub is pretty extensive, and there I'm pretty certain there is an SNMP directory in there.
Okay, but it must be a receiver. I think this is the main problem for nearly every Nagios or status-based monitoring system, and yeah, would be great if it's in Sensu.
Yeah, you'd have to have some component that gets the trap and then triggers an event. The event triggering itself will be just talking to 3030 there, but the tricky thing is receiving the trap itself.
Okay, no more questions? Okay, thank you.
Oh, there's another one back there.
Okay.
How do you handle user roles in the console, in the dashboard? Can you create different roles for, I don't know, the database admins or the people that is only monitoring the infrastructure or the application? Can you create?
As far as I know, the default dashboard, the Uchiva dashboard doesn't have that capability, but there are additional dashboards out there that might. So there's something called Sensu Admin, I think, which would be worth a look. If not, you'd be able to at least build something yourself via the API that will give you all the information you need. As always, if it's not in open source, you will still be able to build it yourself.
Okay, so thank you, Jochen.
As I told you, this was a great discussion, and thank you.